Hey guys, welcome back to chapter 16. In the last video, we talked about how to calculate cell notation for electrochemical cells. What we're going to look at in this video is how do we symbolically represent this. So of course we're chemists, right? We're not going to write all of these words out. We've of course have a shorthand way of depicting these voltaic cells. So that's what we're going to talk about in this video. So line notation is a compact way to represent electrochemical cells. Okay? If we think about the electrochemical cells that we had something that looked like this. So we had half cell here, half cell here, connected by wire. And then inside of the half cell, we had our anode, cathode, and then down here was a solution, right, with some sort of ion. Just a quick reminder of what these electrochemical cells look like. In the line cell notation, we are going to represent this picture, but with words. So the way that we're going to do that is the following. We're going to have one of the electrodes, so anode or cathode, a line, then the electrolyte associated with that electrode, two lines to represent that connective wire, the solution, and then the other electrode. So this is how it's going to go. It's going to go alphabetical like it always has. Anode, oxidized, reduced, cathode. So this is going to be our anode, whatever the piece of metal was in the first half cell. This is going to be the electrolyte that's dissolved in solution, right? So the zinc was dissolved in zinc nitrate, right? So that's going to be whatever that solution is. Then over here, we're going to have our electrolyte that's reduced. So that's going to be the solution on the other side, and then the cathode is going to be that piece of metal. Okay. So if we look at the reaction that we've been looking at for all of these series of videos, it was the copper and zinc reaction. Remember, we had our zinc electrode, anode here. We had zinc nitrate here, and then on the other side we had our copper cathode, and then our solution here was copper nitrate, right? So when we write this notation for this particular example, we're going to start with our anode, which is zinc. Then we're going to do the electrolyte, or whatever the solution was that was oxidized. So that's going to be our zinc ion. That represents kind of the separation between the two cells. Then we're going to do whatever our electrolyte was on this side. So that was our copper. And then lastly, the cathode, the solid piece of copper. So that's the line cell notation for this particular reaction. So why don't you guys go ahead and pause the video and see if you can draw the line cell notation for this reaction. You can go ahead and assume this is how the reaction takes place, and that this is our anode and this is our cathode. So for this one, we're going to start with our anode, which is Pb. Then we're going to write the electrolyte that forms that. So that lead ion. Separate the two half cells. Then we're going to do the electrolyte for the other half cell. And the cathode. So easy peasy. That's how we do line cell notation. If I were to give you this symbol right here, like the notation itself, you would be able to draw a voltaic cell, or you should be able to write the equation for that particular example. I hope you guys found this helpful.